Let's talk about the unit circle and special triangles. The first special triangle we want to talk about is the 30, 60, 90 degree triangle. Now we can derive a 30, 60, 90 degree triangle from an equilateral triangle. An equilateral triangle has three congruent sides of equal measure and three congruent angles of equal measure. Here's a picture of an equilateral triangle. Each side has a length of 1 and each angle has a measure of 60 degrees. Now we can derive our 30, 60, 90 degree triangle by constructing an angle bisector in the equilateral triangle that we see here in this triangle. When we construct an angle bisector in the equilateral triangle, we create two right triangles. We have an angle of measure 30 degrees, we have an angle of measure 60 degrees, and we have a right angle. These two diagonal sides have a length of 1, which is the same in our original equilateral triangle. And the base, which had a length of 1, is now divided in half. So each side of the right triangle has a base of length 1/2. Now when we derive the 30, 60, 90 degree triangle from the equilateral triangle, we know the length of the base and we know the length of the hypotenuse. But we need to use the Pythagorean theorem to find the length of this leg here. So 1/2 squared plus b squared equals 1 squared. And that equals 1/4 plus b squared equals 1. And subtracting 1/4 from both sides of the equation, we end up with b squared is equal to 3 divided by 4. And taking the square root of both sides of the equation, we're left with b is equal to the square root of 3 divided by 2. So now we can create trigonometric ratios for our 30 degree angles and our 60 degree angles. So cosine of 30 degrees is the square root of 3 divided by 2 over 1, which is the square root of 3 divided by 2. Cosine of 60 degrees is going to be 1/2 divided by 1, which equals 1/2. Sine of 30 degrees is 1/2 divided by 1, which is equal to 1/2. And sine of 60 degrees is the square root of 3 divided by 2 all over 1, which is equal to the square root of 3 divided by 2. Now let's look at another special right triangle, which is the 45, 45, 90 degree triangle. Now this is a right isosceles triangle. An isosceles triangle has at least two congruent sides and two congruent angles that are opposite the congruent sides. So the length of these two sides is 1, and the measure of these two angles is 45 degrees, and then we have our right angle, which is 90 degrees. Now in our 45, 45, 90 degree triangle, we know the lengths of the two legs, but we weren't given the length of the hypotenuse, but we can use the Pythagorean theorem to find the length of the hypotenuse. So 1 squared plus 1 squared equals c squared. And that is 2 is equal to c squared. And when we take the square root of both sides of the equation, we get the square root of 2 is equal to c. So now we can use these sides to help us find the trigonometric ratios for cosine and sine. So cosine of 45 degrees is equal to 1 divided by the square root of 2, which simplifies to the square root of 2 divided by 2. And sine of 45 degrees is also 1 divided by the square root of 2, which is equal to the square root of 2 divided by 2. Now we use the trigonometric ratios from our special right triangles to derive the coordinate points for the unit circle in the coordinate plane. Cosine represents the x values and sign represents the y values. So here's a picture of the unit circle with the coordinate points for the common angles that we find in the unit circle. So at 0 degrees we have the point 1, 0. At 30 degrees we have the point the square root of 3 divided by 2 and 1/2. At 45 degrees we have the point the square root of 2 divided by 2 and the square root of 2 divided by 2. At 60 degrees we have the coordinate point 1/2 and the square root of 3 divided by 2. And at 90 degrees we have the coordinate point 0, 1. Now these coordinate points repeat all around the unit circle, and they are symmetric with respect to the y-axis and the x-axis. In this first quadrant, the values will both be positive. In the second quadrant, the x value will be negative and the y value will be positive. In this third quadrant, both values will be negative. And in this fourth quadrant, the x value will be positive and the y value will be negative.